Hello, good evening, students. All right, so today I'm going to send you 11 years board papers. Which topic is that? It is nothing but electrochemistry. So, we very well know term 2 syllabus, electrochemistry and chemical kinetics are the numerical based chapters, right? So, I'm going to send you all starting from 2010 till 2021. I've included the CBSE sample paper also. Yes, so from 2010, gradually I'll be doing 2 marks numericals, I'll be doing 3 marks numericals, I'll be explaining in detail with formula, the procedure, how to do it, everything. Let's start with the video starting from 2010 to 2021. All the best, students. Please like the video, share the video, and ask your friends to subscribe to the channel because we are going to come up with loads and loads of content for your term 2. All the best. Let's start with the video. Hello, students. Welcome to one more session of your WOC. Today, as mentioned, we are going to do complete 11 years paper, students. How many? 11 years. So basically, I'm going to solve each and every numerical from starting from 2010 to 2021 sample paper. Everything, all the questions I'm going to solve, everything are your CBSE board papers. Yes, everything I have collected for you all, and I'm going to solve and teach you. Which topic are we going to do? We are going to do for electrochemistry. Electrochemistry is a numerical based chapter, and you need to compulsory learn each and every concept of this. All right, let's start, students. So my request, please like the video, share the video, and subscribe to the channel. Inform all your friends. We are going to do complete term 2 one by one. I'm going to do till now. I have completed, yes, if I have to tell you, I have completed topics like, all right, aldehydes. Yes, I have done ketones and carboxylic acids. I have done topics like coordination chemistry. Yes, now after that I have done now, as I mentioned, we are going to do electrochemistry now. Then we will go to chemical kinetics. We are going to do amines, like that. All the term 2 we are going to do. So let's start off with electrochemistry. Please like the video, share the video, and subscribe to the channel, students. All right, yes. So before that, if I have to tell you, you all know I'm a verified educator at an academy. So please use my code Vani10. Yes, or Vani Live. If you want to join on the platform, the biggest platform, online platform, an academy, if you use my code, you will be getting 10% discount. Yes, 10% discount would be there. Use my code Vani10 or Vani Live to join the platform. Let's start off the session. The question goes like this. Right, this is your 2010 board paper. Let us read the question and solve it. Now read the question, students. What did they give me? The question given, determine the values of equilibrium constant Kc and delta G naught for the following reaction. This whole reaction is given to us. Yes, they're asking me to find the value of Kc. I have also should find the value of delta G naught. All right. So first of all, always remember, students, yes, your formula for delta G naught, you have already studied. What is the formula for delta G naught? Delta G naught is equal to minus NFE naught cell, correct? Na? That's the standard Gibbs free energy at the electrode potential value E naught. Perfect. Right. So what is N here? N is the number of electrons gained or lost. So let us first start this. N, how much is N from here? Just see, from nickel to silver, how many electrons? N transferred here is 2 electrons. So minus 2. What is 1 Faraday equal to 96,500? How much is the E naught value given to you? It is nothing but 1.05 volts. Easy, students. So delta G naught value, if you multiply this, easy, I'll be getting an answer of delta G naught is equal to, easy, students, almost 96 to 1.5. It is nothing but 202600 joules. It is free energy, that's in joules. What is the next thing I have to find out? I have to find the next one, that is nothing but Kc. Yes, what is Kc value? How do you find? See, there is a formula for relating between delta G naught and your Kc. Yes, so what is the students? Carefully see this formula. Delta G naught is equal to minus 2.303 RT log K at equilibrium constant. Yes, yes, students, at equilibrium. So remember, now what am I going to do? I'm going to introduce the values. So delta G is equal to minus 203 2.303. R value is how much? It is nothing but 8.314. How much is log K? I don't know. I have to find out log K. Delta G naught value I already know. It is nothing but 202600 joules is equal to minus 2.303 into 8.314 into log K. Correct, students? So I want this K log K outside. So I'll take out this and I solve the K value, and what answer? I'll be getting an answer of. So I also did a video where I said use or how to find log without log table. How to find log without log table. I have also done that without log table. So I have done that video. Please watch that video. So you will be getting an answer of around 3.16 into 10 raised power of minus 30, around 36. Yes, it's a constant. Around 36 I'll be getting it. Easy question, very easy question. So the first question is over. Let us do the next question. So what do they give me? A Voltac cell is set up at 25 degrees with the following half cells. So much is a concentration given for both. Write the cell reaction when the cell or when the cell generates an electric current and determines the cell potential. This value is given to me. So what should I write? I have to write the cell reaction first. Let us take the cell reaction first. Yes, anodic reaction. Yes, students, anodic reaction. At anode, first of all, what is happening? Electrons are getting transferred from aluminium to nickel. Correct, na? Electrons are getting transferred from aluminium to nickel. So at the anode, loss of electrons will happen. What will happen? Al plus 3, it loses 3 electrons. Perfect. Then what is happening? Nickel is going to accept those 2 electrons from aluminium and it's going to form nickel solid. Correct. Now electrons should get cancelled. So what will I do? I am going to multiply this whole thing with 2 and I'm going to multiply this whole thing with 3. Correct. So electrons get cancelled now. The electrons get cancelled. What is left out? So multiply the whole thing. 2 into aluminium is 2 aluminium solid plus nickel. How much? 3 into nickel. 3 into nickel aqueous. Correct. This also gives. Then next comes 2 into aluminium plus 3 aqueous. And next comes 3 into nickel solid. Easy, students? Easy? Very easy. So this is your cell reaction. This is done. After that, they said what when like and determine the cell potential. I have to find the E cell also. So first of all, let us take the Nernst equation. According to the Nernst equation, what is it? E cell is equal to E naught cell, correct, minus 0.0591 by n, correct, log of, yes, your oxidized part by reduced part. Oxidized by reduced part. Correct, na students? Yes. Let me take one more slide, students. There is no place. Let me add some more slides and come back. So 1 second. Let me add the slides and come back again. Alright, so we have written the Nernst equation. Done, students. Now what are we supposed to calculate? We are supposed to calculate E cell value. So E cell is what is the question. Now let us take one value and understand. First of all, E naught cell is what? Basically, we have seen the formula. E naught cell is equal to E naught cathode minus anode. Correct, na? Cathode minus anode, E cell rather, E naught cathode minus E naught anode. So what is a cathode here? In this case, it is nothing but nickel. So E naught nickel plus 2 by nickel minus E naught Al plus 3 by Al. Correct, now students? How much is nickel given to us? Nickel given to us is minus 0.25. Aluminum given to us is minus 1.66. So substitute the value here. Here it is minus 2.5 volts minus of minus 1.66 volts. How much will it come to? So this is nothing but E naught cell. This is nothing but E naught cell, right? So when I substitute E naught cell, I'll be getting 1.41 volts. Done. Over. Now E naught cell is ready for us. Now what is the next thing? What is the oxidized part? Because I have to do this oxidized part. Now check, students. Here in this case, the oxidized part of the whole thing is for aluminium. This one. What is the aluminium concentration given to us? Here the aluminium concentration is given here, and I can write it as 10 raised to minus 3 also. This is your oxidized part. Done. And oxidized part, and this is your reduced part. So let us come and substitute in the reaction given, the Nernst equation. So E cell is equal to 1.41 volts minus, how much is it? It is 0.0591 equation. How many electrons got transferred from nickel? I already saw 6 electrons I have cancelled. So 6 log of oxidized is 10 raised to the power of minus 3. Yes, raised to the power 2, because aluminium, we have seen balanced equation. Yes, it is the coefficient. Divided by reduced part is 0.5. When I balance nickel, it is nothing but the coefficient is 3. Correct, now students? Alright, so this is this. Further, if I can simplify, yes students, you very well know 10 raised to the power of minus 3, I can write it as 3 log 10. Correct? 3 log 10. Log 10 is 1 only. Correct? Yes, this one also I can write under base 10. So when I solve these two, I'll be getting an answer of 1.41 volts, right, minus 0.591 by 6. So when I take the whole thing, right, this whole thing, if I simplify, it comes to log 8 into 10 raised to the power of minus 6. Yes, 3 2s are 6. This is 3 2s are 6, and this is 3, and I took out the decimal. I'll be getting 10 raised to the power of 8. So 8 can I write it as 10 raised to the power of 6. 8 can I write it as 2 cube. Let us write that. E cell is equal to 1.41 volts minus 0.0591 by 6. Yes, I can write this as log 2 cube. Correct, na? 8 plus log 10 raised to the power of minus 6. Correct, na students? Further, let us simplify. When it is a raised to the power of b, log a raised to the power of b is nothing but b log a. B log a. Correct? This is what is the thing. So now let us write. Do I have a next page? I don't have. So I'll be taking one line here. Sorry for the very vague line. So I'm going to write the same thing as E cell is equal to, yes, 1.41 volts minus 0.0591 by 6. I'm writing 2 log 3 as place is not there. So I'm writing it as 3 into log 2. Can I write? Same thing. Yes, 3 into log 2 plus, right? So 10 raised to the power of log 10 raised to the power of minus 6 can be written as, right, I can write it as minus 6 log 10. Correct, na students? Same thing which I have thought easy. So minus 6 log 10. Log 10 is already 1. So further I'm going to simplify this as E cell is equal to 1.41 volt minus 0.0591 by 6 into, there is no place, that's the reason students, into 3, I'm putting like that. Log 2 value is 0.3010. Correct, right? Minus is here after that, and then comes your 6 minus 6. Correct, now students? Right. Sorry for the inconvenience. Place is very less. That's the reason I'm writing. So this is whole factor. You understood, I think. I simplified it. I have written. So the final answer, once you add and subtract, the final answer which you are going to get. So let me write the final answer here. Yes, students, the final answer, if you solve 1.41 minus 0.0591 by 6 and all these you multiply, you'll be getting E cell value equal to 1.46 volts. Right, students? Easy? Is very easy sum. Right? I've explained everything. Let us see one more question. That is nothing but your 2011 paper. So just check. Careful. Easy question. Nothing to get confused. Relax yourself and do the sum. Right. Now 2011 paper. Calculate the potential of a half cell containing, this is given to you, potassium dichromate 0.10 molar, chromium is 0.20 molar, and H plus is so much. What is your work? You have to find standard electrode potential. No, they have given you standard electrode potential. E naught is given to you. What is your task? I have to calculate the potential for half cell. That means, what should I calculate? I need to calculate E cell. E cell is how much? Correct, na? Let us write the formula. First of all, if I have to see, the formula for this is E cell is equal to E naught cell, correct, minus RT by NF, correct, log. It is oxidized part by reduced part. What is oxidized here? Here, when I see chromium is oxidized, how much? Cr plus 3 raised to, and what is reduced? It is chromium and chromium oxide and as well as proton. Both are there here. In this case, let me take CrO7 minus 2 and your H plus value. How much? It is 1. How much is the coefficient? 14. H plus and it is 14. This is your basic equation. Now, let us start calculating 1, 1. First of all, E naught cell. How much is given? It is 1.33. Let us substitute that. So, the first equation, let us write E cell is equal to, how much is E naught cell? 1.33 volts. Minus, I multiply R value, I multiply T value. How much do I get? 0.0591. Correct. How many electrons got, how many electrons got transferred? 6 electrons. So write that n value as 6. Right. Next is log. How much is the concentration, students? Oxidized part, that is chromium, is how much? 0.2 molar given to me, square. That's a coefficient, divided by chromium. How much is given to me? 0.1 molar. Done. How much is H plus given to me? H plus is given to me 10 raised power of minus 4 and 14. Done, students. This is the thing. Let's take further simplify. E cell is equal to 1.33 volts minus. First, always try to simplify the log part. Okay, log part. So when I take this, what is this, students? It's nothing but just take 0.220 rather 0.20 molar and square. Right, and below you have 0.1 molar and 10 raised power of minus 4 14 times. Yes, so multiply 14 fours are right. After that, make this under base 10. How much do you get this? This becomes log 4, the numerator, plus when you simplify, this becomes log 10 raised power of minus 55. So you have got both into log values, correct? So this log 4, further you can simplify and you can write it as 1.33 volts minus 0.591 by 6 log 4. Can you write it as 2 log 2? Yes, I can write it as 2 log 2 plus minus 55 power becomes 5 log 10 because your log 10 is 1. Correct. Now further you simplify. E cell is equal to 1.33 volts minus 0.0591 by 6. Okay. 2 into what is log 2? 0.3010. How much is this? Log 10 is 1. Correct. So what is left? Only 55. Correct. Further we simplify, multiply and do it. You will be getting a value of E cell is equal to, means I am simplifying this whole thing, I'm multiplying this, I'll be getting 1.33 volts minus 0.548, because I worked out already, so it's easy for me to write. So when I solve this, I get 0.782 volts. Simple. They have asked me cell potential. So cell potential for the particular cell is so much. Easy, students? Right. Let us see one more. Right. So basically, Voltac cell is set up at 25 degrees centigrade with the following half cell. This is what is given. Two concentrations are given to us. Yes. Did we do this sum basically earlier? Yes. The same question is repeated. Yes, students. Nickel, aluminium. The same question is repeated in 2011 also. Right. So the same question as we have done is done, but little bit any change in the equation, everything is same. They have done the same concentration, the answer, the same formula, everything is given the same. So the same thing is repeated again in your 2011 also. So same question as which year, students? We have done the same question earlier also in 2010 paper. So I've already solved it. So take the question, go through it, and done. So this is solved already, solved in 2010 paper. Okay, done. Check. This is also solved in 2010 paper. Just now we have done. So please go through the same question is repeated. Next question, 2012 paper. The electrical resistance of 0.05 sodium hydroxide solution of a diameter of diameter of 1 centimeter and length 50 centimeter is so much. So they have given this value. What should I find? I have to find its resistivity, conductivity, and molar conductivity. Easy, direct formulas. Let's write. First of all, let me see. I have a page. Yes, I have a page. Let me do it. First of all, resistivity formula is what? Yes, students, R is equal to, or resistance is equal to resistivity to L by A. Take out this resistivity. Rho is equal to A R by L. Am I right? Yes. Now, just see here. What is given? Length is given. Okay, let us write what is given to us first. First of all, area of cross section is equal to pi r square. What is pi? Pi is equal to 3.14. What is the this one given to us? The electrical resistance 0.04 and the length is so much is 5.55 10 raised to 3 ohm. Okay, so how much did they give me? So 3.14 radius is how much, students? Right, length and diameter also is given. Yes, radius, okay, it is 0.5 square. A value is equal to, how much is it? 0. It comes to 785 centimeters square. Done. Okay, A is done. How much is length given? Length given is 50 centimeters. Now substitute the whole thing in the formula. Okay, so rho is equal to 5 point. How much is area of cross section? How much is area of cross section? So once I solve this, I'll be getting 5.55. How much is resistance given to me? It is nothing but, means, no, basically how did I get that? See here, resistance is your value of 0.05 molar solution. So much is the thing, right? Electrical resistance of 0.05 molar solution, that's it. Okay, so 0.55 into 10 raised power of minus 3 into, yes, what did I get? 0. Area of cross section is 0.785 divided by what is length? 50 centimeters. Correct na? So how much do I get? Resistivity, rho, I got it as almost, I'll get when I have checked, it is 18.18 centimeters. Done. This is okay. Next I have to do conductivity. All right, so conductivity is denoted by an alphabet. What? It is nothing but kappa, which is equal to inverse of the resistivity. Yes. So resistivity I already got 1.87 by 8 ohm centimeter. If I solve around, I'll be getting around 0.1147 joules. So basically, this is already, I have solved it. So it's easy for me to write. What is left out? This is molar conductivity is left out. So molar conductivity, that is denoted by an alphabet or M. Yes. What is it equal to? 1000 into K by C. How much? How much is K value? 1000 into, yes, K value is 0.01147 divided by conductivity. How much is it, students? It is 0.05. No? Correct? The particular thing, it is inverse. Resistance is the inverse of that. Correct? So conductance, nothing but 0.05. So the reverse of resistance is conductance. So when I solve this, I'll be getting a value around 229. I got 229 for so Siemens centimeter square mole inverse. This is the unit. Okay, I got this one. So I got conductivity value. I have got molar conductivity value. I have got resistance. Easy. Let us see the next question. The molar conductivity of 1.5 molar solution of an electrolyte is found to be so much. Calculate the conductivity of the solution. Okay, so I have to check what I have to find K. How much? What is given? Molarity. Okay, let us check how much is molarity given. 1.5 mole. Right. Then what did they give me? Molar conductivity they have given. Lambda m, or you can write it as delta, or you can write it as lambda. How much is it? 138.9 Siemens centimeter square mole inverse. So what is the formula? Into the m into capital M by 1000. So how much is molar conductivity? 138.9 into, or 889 Siemens centimeter. Molarity is how much? 1.5 divided by 1000. How much did I get? 0.208 Siemens centimeter inverse. Easy, easy, students. It's a direct formula substitution. Let us see one more 2013 paper. Little bit blurred. I couldn't get the picture. So this is what I got. So a voltaic cell is set up at 25 degrees with the half cells. This is given. This is one half cell. This is one more half cell. What will be the cell potential? I have to calculate what cell potential. I need to calculate E cell is how much. Done, students. Log value will be given like this. We will see how to utilize. As the reaction is given to you, first write the cell reaction. So see here, from silver to copper, how many electrons? 2 electrons are going. So check carefully. Anodic reaction. Anode, what is happening, students? At anode, copper solid is giving copper plus 2. How much is the concentration? 0.10 molar plus how many electrons? 2 electrons. At cathode, what is happening? Silver is taking up those two. Okay, silver plus 2, because 2 electrons are there, is taking up those 2 electrons. How much is the concentration? 0.001 molar. Taking up those 2 electrons and forming silver solid. Done. Now, so total number of electrons is how much, students? Now n is equal to 2 electrons got transferred. Okay. Now let us write the Nernst equation. What is Nernst equation? E cell is equal to E naught cell minus 0.059 by 91 by n log oxidized part by reduced part. What is oxidized? Copper plus 2. What is reduced? Ag plus. How many coefficient? 2. Substitute the value E cell. How much is E naught cell given? 0.46. Let us write 0.46 minus 0.0591 by 2. How many electrons? 2. Copper. How much is this? 0.1. How much is silver? 0.001 square. Done, students? Done. Okay. So 0.1, write it under base 10. 0.01, write it under base 10. So when I solve this, I'll be getting 46 minus 0.0591 by 2. I've solved. I got log 10 raised to 5. Converted into base 10. So can I write 5 as 5 log 10 into 0.0591 by 2 minus 0.46. So E cell is equal to so much. Do I have one more page? Yes, I have one more page. So the same thing we very well know. Let me repeat the statement. So I'm repeating the same thing earlier. How much? E cell is equal to 0.46 minus how much did I get? 0.0591 591 by 2 log 10 raised to 5. So I have written this as 5 log 10. 5 log 10 is nothing but 0, 1 only. Sorry, log 10 is 1. So I will ignore that 10 and make this equal to E cell is equal to 0.46 minus 0.059 by 2 into 5, because since log 10 is 1. Correct now? So when I simplify, I'll be getting an answer of around 0.3125 volts. Simple. All sums are simple, students. Easy? Let's see. One more. Oh, big question. So a strip of nickel metal is placed in 1 molar solution of nickel nitrate, and a strip of silver metal is placed in 1 molar solution of silver nitrate. Okay. An electrochemical cell is created when two solutions are connected by a salt bridge and the two strips are connected by wires to a voltmeter. What is my task? I have to write cell reaction. Okay, done. I have to find out cell potential. Okay, E cell, done. And they have given the concentration of nickel so much. They have given the concentration of this and the electrode potential values. Let us start writing. First of all, which one is undergoing oxidation and reduction? Observe carefully. As we have seen, nickel is undergoing oxidation. How did I know this? The electrode potential value. Seeing the electrode potential value, negative value, I have understood that it is oxidation potential. Done. Right. Let us start writing the equation. First of all, here only I have place. Let me take the first one. Anodic reaction, what is happening? Nickel is losing 2 electrons and forming nickel plus 2. Okay. Then cathode. What is cathode doing? Cathode, what is there? Silver. Silver is picking up 1 electron, right, and forming silver. Ma'am, electrons are not balanced, so you're going to multiply it with this 2 electrons. So overall cell reaction, what do I get? 2 electrons get cancelled and 2, okay, electrons got cancelled there, so it is Ni solid plus 2Ag plus gives me Ni plus 2 plus 2Ag. Done, students. This is the overall reaction. First thing is over. Okay, first thing is over. Then I should calculate cell potential value. Okay, so to calculate the cell potential, I'll be using Nernst equation. Always cell potential I can calculate using Nernst equation. How much is it? Formula. This is the formula. Correct. So this is the formula by log. What is oxidized? Nickel. Okay. What is reduced? Silver. How much is the charge coefficient? 2. Done. Now, how many electrons, students? 2 electrons. So, E naught cell we will calculate first. Let us calculate. So, let me calculate E naught cell is equal to E naught cathode minus E naught anode. Correct? Okay. How much is cathode value? 0.080. Minus of anode value is 4 volts. So finally, E naught cell I got it as 1.05 volts. Done. Done. Now substituting the Nernst equation, E cell is equal to 1.05 volts minus 0.0591. How many electrons got transferred? 2 electrons. 2 log oxidized part is how much? How much is nickel value, students? I got it as nickel is 0.1. How much is silver? 1. So nickel is 0.1, silver is 1. But what is the coefficient? 2. Remember that. This coefficient you should not forget. Now I said once you get this, write under base 10, mean 10 raised power of minus 1, like that. When you write it, what do you get? E cell is equal to 1.05 volts minus, I'm solving that 0.051, I'll be getting 0.0295, and that value when I multiplied 10 raised power of minus 1, na, 0.1 is its log as, correct. So can I write it as 1 log 10? 10 raised power of minus 1? Yes, I can write like that. So when I solve this 0.05, yes students, so 10 raised power, this is minus, na? So this gets converted to plus now, 0.025, which is equal to 1.0795 volts. Easy, easy? Yes, easy. So this is how you got the cell potential. Let us solve the 2014 paper. Calculate delta G naught for the reaction. Okay, they have given me a cell reaction. E naught cell is given to me, Faraday value given to. Easy. Delta R G naught is equal to minus N F E naught cell. How many electrons got transferred? 2 electrons. What is Faraday? 96,500. What is E naught cell? 2.71. Easy. Delta G naught is equal to, when you multiply, minus 523 around. When I solved it, I around got an answer like this. This is what is an answer I got when I solved it. Easy? See. Let us see 2015. Okay, this is empty. This is blank. So let me write the answer. Delta G naught value got is minus. This is the answer which I got already. I solved the question. So for me, I remember the answer, so I'm writing it. You see, 2015 paper. Okay. The following reaction occurs at cathode during the electrolysis of aqueous silver chloride solution. All right. So they're asking me, on the basis of the standard electrode potential E naught, which reaction is feasible at cathode? Simple, students. Remember, seeing the electrode potential values, we very well know, higher the positive values, rather higher the positive electrode potential values. What do we call them? We call them as standard SRP standard, because it is E naught value standard. So higher the electrode potential values means higher the standard SRP values are maximum, and reduction always happens at where? Cathode. Correct, na students? So what is the thing? What should you remember? So here in this case, silver aqueous is taking up one electron and it is forming silver Ag. So this particular reaction, because seeing the positive SRP value, the reaction is feasible at which electrode? At cathode. Based on what? Higher SRP. Higher SRP. SRP means the positive reduction potential. Done? Very good. Next question. Calculate EMF of the following cell at 25 degrees. They have given me cell notation. I have to calculate the EMF of the cell. Nothing but E cell. Yes. So, first of all, see what is the formula? E cell is equal to E naught cell minus, same thing students, it is easy, in oxidized part by reduced part. Oxidized by reduced part. Now observe, first of all, first we'll calculate E naught cell. E naught cell is what? It is E naught cathode minus E naught anode. Correct? How much is E naught cathode? What is E naught cathode here? Just see. One is hydrogen electrode. This is SHE, standard hydrogen electrode, and this is negative reduction, negative electrode potential, that is oxidation part that happens at anode. So cathode, hydrogen is there. If you have a negative value, it is nothing but the oxidation potential value. Correct? This is your, oops. So E naught cell value, I got it as 0.44 volts. Clear, students? Now take it and apply it in the Nernst equation. E cell is equal to 0.44 volts minus 0.0591 by 2. log. Oxidized part is how much? 0.001. How much is reduced part? 0.01 square. Now you can write this as under base 10. You can write this is base 10, this is base 10. So when I solve that, I'll be getting an answer, I'll be getting a value of, just you only check students, I can make this under base 10, this also base 10. When it goes up, everything get cancelled and I'll be getting log 10. Log 10 is nothing but 1 only. So E cell is equal to 0.44 minus. So already I have solved this. So I got an answer of approximately 41 almost. Yes, students, this is your EMF of the cell. Let us see 2016 paper. Calculate EMF of the following cell. This is given to me. They have given me a cell. They have given me electrode potential values. First, I have to check which is oxidation, which is reduction. Yes, students. So observe carefully. Observe carefully. In this case, it is 0.74 volts. In this case, it is minus 0.44, which is higher, students. This is your reduction potential value, correct na? This is your reduction potential value. This happens at the cathode. This is your oxidation potential value. This happens at the anode. Let us do which formula I'll use. E cell is equal to E naught cell minus 0.059 by N log oxidized is what? Chromium plus 3 2 times, because the coefficient is 2, divided by, yes, iron Fe plus 2. How much is the coefficient? 3 is the coefficient. Now first we will calculate E naught cell. Okay, so we have seen the electrode potential values. So E naught cell, cathode minus anode, how much is it? 0.44 volts minus of minus 0.74 volts. Done. How much will you get? Minus into minus is plus, so 30 volts. So E naught cell value I have got so much. Now substitute in the Nernst equation. Okay, E cell is equal to E naught cell. Okay, how much did I get, students? I got 0.30. Okay, let me write the formula first, and then again I will write it again. Okay, this is what I have written. Now let us substitute. E cell is equal to 0.30 minus 0.059 by electrons transferred as 6. Correct na? Yes, 3 into 2, 6 electrons. Right. When I solve this, right under base 10, yes, you will be getting 0.1. This again you'll be getting as log 10 only. It's 1. So I'm solving this and I'm getting a value of 0.3098 volts. So convert this under base 10, right? And the denominator, again 10 is of 1. Take it to the numerator, subtract it. You'll be getting log 10, which is easy, students. Let us do 2017 paper. The cell in which the following reaction takes place. Calculate standard Gibbs free energy. Easy. I should do this part. This is what I have to do. Correct? Okay. So let us check. In this case, how many electrons got transferred? See here. 2 electrons. See here. 3 into 2, 2 into 4, 7 minus 2. Okay. It is almost 2 electrons got transferred. Plus 2. So plus 2 and minus 2. So minus 2. Faraday is how much? 96,500 coulombs. E naught cell is how much? They have given me 0.236 volts. Now you calculate. You'll be getting an answer around. I got it as 4, 5. Check whether it is. You have also got the same answer. If I take this, if I convert into kilojoules, it becomes 45.548 kilojoules per mole. Because can't, we will simplify it and make it nearby to the significant figure. You see? Easy. Right. 2018 paper. The conductivity of 0.01 molar solution of acetic acid is so much. Calculate the molar conductivity of the solution. Easy. They're asking me to find out molar conductivity. Correct. How much is K given? 1.65. 10 raised to the power of minus 4 into 1000. How much is C given to you? Conductivity 0.0. Simple. Multiply. I got an answer of around 16.5. So what are the units? Conductivity is ohm inverse, because 1000 by C means the volume, right? So 1000 10 raised to the power of 3, and your concentration, that's nothing but mole. So 10 raised to the power means this becomes centimeter square. That's the unit for conductivity into 1000 and mole inverse. So this is your answer. Easy, students? Easy. Let us see one more question. Based on the data, Fe plus 2, Mn plus 2 and Cr plus 3, in the increasing orders, or means you have to arrange in the increasing order of the stability of plus 2 oxidation state. See here, electrode potential values are given. Correct? Now first see, when I take the first one, the electrode potential value of iron is higher than chromium. Correct? Now, this is plus 8, means 0.8, this is 4. So first of all, electrode potential of Fe plus 3 by Fe plus 2, correct, is higher than that of E naught cell Cr plus 3 by Cr plus 2. Correct? This is higher. This value is higher. So then this. When I compare between Mn, so electrode potential value of Fe plus 3 by Fe plus 2 is less than electrode potential value of Mn plus 3 by Mn plus 2. Am I right, students? Yes. So which one is easy? So reduction of Fe plus 3 is easier than reduction of Mn plus 2. Correct? Fe plus 3 reduction, because this is lesser than Mn plus 2 value. So I can easily reduce Fe plus 2. Means Fe plus 3 to Fe plus 2. Correct? So what is happening now, students? Reduction of Fe plus 3 to Fe plus 2 is easy. Easy. Yes, because it is greater than Cr plus 3. Correct? So this is easy reduction. Easy. But Mn plus 2 is very difficult, right? And but if I compare with Cr plus 2, no, it is not. It is not as easy. Reduction is not easy. And that's why if I see the reduction potential. So what is the understanding now? Here, Fe plus 3 is more stable than Mn plus 3. Correct? Fe plus 3 is less stable. Okay, if this is confusing, I'll write here more stable. This is less stable than Cr plus 3. Correct? So what is the increasing order, students? Seeing the electrode potential, box is very bad. Mn plus 2 less than Fe plus 3 less than Cr plus 3. Increasing order of stability. Increasing order of stability. Alright, students, seeing the electrode potential. So simple. So electrode potential value of Fe plus 3 is higher than, it's very higher than, yes students, higher than chromium and lower than manganese. That's point number. So which is easy? I can easily reduce Fe plus 3 to Fe plus 2. Correct? Gain of electrons is easy. So, but when I see Cr plus 3 to Cr plus 2, not much easy. Correct? So this is the order which I have given. 2019 paper. E naught cell of the given redox reaction is so much. Okay. What should I calculate? I need to calculate E cell. Write the direction of flow of current when an external and opposite potential is applied. Applied is less. Okay. Direction of flow of current when an external, the opposite potential is applied. Now, first let us calculate E cell. E cell is equal to E naught cell minus 0.059 by N log Kc. Correct? Yes. So, right. Now observe carefully. Here in this case, Why did I take Kc? Because you can write it as oxidized and reduction also, not a problem. But the basic thing for equation equilibrium. But if I write cell, actually I should write this one, oxidized part by reduced part. What is oxidized here in this case? Yes, magnesium. That's nothing but 10 raised power of minus 3 divided by copper, 10 raised power of minus 2. So you can write this as 3 log 10, right? Now you can write this 3 log 10. So what will you get? cell is equal to 2.71. Yes, that's already given. Yeah, right. Plus when you solve this equation, this is 3 log 10, 2 log 10, correct? And you take out the 10, 10 is log 10 is 1, log 10 is 1. So when you divide, and you get an answer of 0.029. So E cell value, when I did, I got an answer. Please check your answer with this. Next, they've asked me, write the direction of the flow of current when an external and the opposite potential applied is less than 2.7. So always remember, if it is less, the potential applied is less. So what is happening? Always flow of current always happens from which direction, students? Current always happens from cathode to anode only. Cathode to anode only, whatever is the potential. Correct? That means from copper to magnesium. Same direction. And next question is greater than 2.71. We very well know always electrons flow from magnesium anode to cathode. Flow of electrons is from anode to cathode. Anode to cathode. Which one? From magnesium to copper. Correct, now students? Magnesium to copper. Easy. Opposite direction. This is same direction. This is opposite direction. Easy. Chalo. Next question. In the plot of molar conductivity, this one they have given 2 versus square root of C half. The following curves are obtained. This is nothing but variation of conductivity in students. Right. So they are asking, predict the nature of electrolytes A and B. What happens on extrapolation of lambda m or molar conductivity to concentration approaching 0 for electrolytes A and B. Okay, I have to predict what is A, what is B. First of all, students, first question let us write. So A is nothing but the graph for strong electrolyte. Correct, no? Yes, straight. Second graph is, because when you join, you'll be getting a concept of limiting molar conductivity. But for weak electrolytes, you can never join it. B is nothing but it is a weak electrolyte. B graph is a weak electrolyte. So they asked you, predict the nature of electrolytes. Okay, what happens in extrapolation when you expand it? Now remember, students, I just now said, when you extrapolate this graph, it's going to meet strong electrolytes will meet at a point, but with an intercept. But weak electrolytes will never, correct? Na? Yes. So what is it? And for weak electrolytes, I cannot be obtained. Cannot be obtained by extrapolation. I can never extrapolate and join it. Right? And not be obtained by extrapolation of the graph. We have already seen this graph. We have already seen, I have explained this in Kohlraasch law also, variation of conductivity of strong and weak electrolytes also. But when you take lambda naught, yes, for strong electrolytes, remember students, as I have shown you, yes, you can obtain strong electrolytes can be obtained on intercept. Correct na? This is what I have obtained. I have taken, this is called limiting molar conductivity. Limiting molar conductivity. Limiting molar conductivity. What is students? Yes. Now, next thing. 2020 paper, right? They have given me calculate delta G naught for the reaction. This is the thing. What should I calculate? I have to calculate delta G naught. Easy. All values are given to me here. Easy. Let me write the formula first. Delta G naught is equal to minus NF E naught cell. Perfect. Okay. How many electrons got transferred? 2. What is Faraday? 96,500. How much is E naught cell? Let me calculate. E naught cell, I will calculate and see. Here, what is the cathode? Observe. This is your anodic reaction. Seeing the electrode potential value, higher negative potential. So, oxidation. This is your cathodic reaction. Let us take the value E naught cell is equal to E naught cathode minus E naught anode. How much is E naught cell cathode? 0.3. How much is anode? 0.76. How much is this value? 1.10. Correct? Now substitute. Delta G naught minus 2 into 1.10 into 96,500. I think when I solved it, I've got an answer of 212,300 joules per mole. I'll convert this into kilojoules. It becomes 212.3 kilojoules per mole. That's easy. Easy. Next question, students. Which of the following pairs predict with reason which pair has greater conductivity of electricity? Okay, 3 conditions are given. Let's see. So remember, silver wire at 30 degrees or silver wire at 60 degrees centigrade. So remember, I will solve the first part. Okay, I have a page. Right, let's see. Always remember, students. Yes, what to remember? First one. As temperature decreases, careful, resistance decreases. Because resistance is decreasing, conductance increases. Got it? Now tell me whose temperature is less? 30 degrees. Correct? So 30 degrees. So silver at 30 degrees will have more or greater conductivity. Got it? Easy. Second one. 0.1 molar acetic acid solution and 1 molar acetic acid solution. Okay, now see here. Here, 0.1 molar acetic acid solution and 1 molar. Now tell me, we have what to remember. Second point. Remember, students? As dilution increases, yes, ionization increases. Hence, conduction increases. So, which one, students? Which one? 0.1 molar is more diluted. Correct, na? 0.1 molar acetic acid has greater conductivity. This is greater conductivity. Why? Because it is more diluted. You see? Point number 3. They've asked me KCl at 20 degree and KCl solution at 50 degree. Same story again. As the temperature increases, mobility of ions increases. Then conductance increases. Am I right? Now tell me, KCl you have which has more temperature? Yes. KCl at 50 degree has which one? Has more conductivity. Easy? Yes. Next, 2021 paper. Yes, we have almost come to the end. Let's see. This is a two marks question. Solutions of two electrolytes A and B are diluted. Okay. The molar conductivity of B increases by 1.5 times and A increases by 25 times. Which of the two is a strong electrolyte? Justify your answer graphically. Okay. Now, remember, students. Here, first of all, I have to decide which is weak electrolyte, which is strong electrolyte. What should I remember? Molar conductivity increases because it is number of moles in one, means number of ions in one centimeter cube of the, like, 1 mole of electrolyte. The electrolytic solution you're considering for 1 mole, correct? So molar conductivity increases as dilution increases, correct? But the molar conductivity slowly increases as the dilution increases. Okay, so as there is no increase in number of ions. Suppose if there is, as a dilution increases, this is the important point, remember. Now in this case, B, how many times? Only 1.5 times molar conductivity has increased. Correct? Means there is no increase in number of ions. Means not much increase in molar conductivity. See, when you see B, when you see A, here it is 25 times of increase, 25 times of molar conductivity increase. That means what is the concept? B is a strong electrolyte. Why strong electrolyte? Because in strong electrolyte, the dissociation, what will happen? Already it is 100% dissociated in this. This is 100% dissociated. There is nothing much, everything completely, it is already dissociated. And you are saying it is 1.5 times. It obviously shows less because already it is completely dissociated. Correct, students? So this is weak electrolyte because it has increased so much, because weak electrolyte dissociation is only 5%. So this particular dissociation shows it is weak. So B is a strong electrolyte and A is a weak electrolyte. Got it, students? Yes, right. Now let us draw the graph. Yes, you're taking lambda m on the x-axis. You're taking root c on the y-axis. So always strong electrolyte, you can extrapolate and you can get the infinite value, lambda infinite value, and weak electrolytes, you can never get the extrapolate. You can't extrapolate it and get the, find the limiting molar conductivity. So this is, let me drink some water, please. Okay, this is strong electrolyte. This is weak electrolyte. You see? Let us see one more. Represent the following cell reaction takes place. The value of E naught for the cell is so much, to 1.260. What is the value of E cell? Okay, there is one reaction given to you. Cell reaction is given to you. So first of all, one cell reaction is given to you. Write the cell notation: solid by cadmium plus 2. Solid activity is 0, no students, only ions. There is a salt bridge, aluminium 0.01 molar, and cadmium is a solid. This is your cell notation. So what should I find? E cell, correct? First of all, what is cathode and which is anode in this case? Yes, so aluminium is a anodic reaction and cadmium is a cathodic reaction. That is oxidized and this is reduced. So E naught cell value already they have given. So take it. E cell is equal to E naught cell minus 0.059 by N log oxidized part by reduced part. You should always write the coefficients. Don't forget that. So E cell is equal to 1.26 minus 0.059 by 2 electrons log, so 0.01 square by 0.1 cube. So simplify, make it as under base 10. This is 10 raised to the power of -2, correct? So into square, solve it. When you solve it, do I have a place? Yes. Okay, when you solve it, you'll be getting a value of E cell is equal to 1.26 minus 0.059 by 6, and that comes as -1 into -1 once I solve it. 10, I made everything to base 10. So when I solve this further, I'll be getting as when I solved, I got this answer, right? So E cell is equal to 1.269 So anything easy, make it under base 10. That's all. Okay, right. So thank you so much for watching, students. My request, please share the video. Please share the video. Share the video to all the students. WC has done almost 1600 plus videos. Yes, students, and it is a free education, free and quality education. So my request to all of you, please share the video to all your friends. Yes, coming up with more and more videos. Yes, students, if you want to join at an academy, my referral code is Vani10 or Vani Live. Join me. I am doing term 2, complete term 2, objective part and subjective part. So please join me. Use my code. You'll be getting 10% discount. Got it, students? All right. Thank you so much. Please like, share, and subscribe to the channel. Always stay happy. Please share the video to all your friends. Bye bye. Take care. Thank you.